So here's the problem. It's got some pieces on it, but we have the balanced reaction up here. Okay. Am I going to apply this? Yes, I will. I wasn't planning on it, but I will now. Okay. So here's the problem. We got a balanced reaction up here, and it's actually got three reactants. Okay, it's CH4, NH3, and O2. They're reacting and they're making HCN and H2O. Okay. So if I start off with 95.0 grams of CH4, 100.0 grams of NH3, and 200.0 grams of O2, what is the limiting reactant? Now, a limiting reactant is the thing that you run out of first. So, for example, let's say you wanted to make some cookies, and I'm going to use the cookies again. You needed 1 cup of sugar, 1 cup of flour, and 2 eggs. If you go into your fridge, though, and you only find 4 eggs, you can only make 2 batches of cookies. Like, that's it, because you need 2 eggs and you only have 4. So that's the maximum amount of like batches of cookies you could possibly make would be 2 batches. It doesn't matter how much sugar and flour you have. If you walk in there and you have like literally a 5-gallon bucket full of flour and a 5-gallon bucket full of sugar, it doesn't matter because you're going to run out of eggs. Okay. So that is what's going to limit is how many eggs here. So if we take a look at this, it looks like our limiting reactant might be CH4 because that's the one we have the least of. However, these are masses, they're weights, and this is amounts. So there's a difference here, and it's probably the hardest thing about stoichiometry to wrap your head around. There's a difference between what it weighs and how much you have, okay? If I have 10 golf balls and 10 bowling balls, those weigh different amounts, even though I have 10 of both, okay? So this is about how many I have, whereas these are weights. So the first thing you need to do, if you are given multiple reactants, and I have 3 of them here, you are going to have to convert these to moles to actually see how many reactants you actually have, okay? So I'm going to start with the 95.0 grams of the CH4. I'm going to convert that to moles. So it is 16.04 grams per mole. The grams goes on bottom. Okay, I know that. I wrote it down earlier. So carbon, hydrogen, hydrogen. Okay, so 95.0 times 1 divided by 16.04 is, my calculator says 5.922. I'm just going to kind of round it off to 7. Okay, and that's more sig figs than I need, but moles of CH4. Okay, so that's the first one. I'm gonna have to do all 3. 100.0 grams of the NH3, and that's a different substance, so a different molar mass. 1 mole of this is 17.03 grams. Okay, so 100.0 times 1 divided by 17.03 is 5.87199. Let's cut it off there. Moles of the NH3. Right? So those are 2 of the 3 reactants. Third reactant, 200.0 grams of the O2. And O2 is 16 and 16. So that's 1 mole is 32.00 grams. Okay. So first step, convert to moles. Yes. All right. So 200 times 1 divided by 32 is 6.25 moles of the O2. Questions on anything I just did? 3 separate problems, by the way. It's like 3 things. Okay, so looking at these numbers, now that I've gotten rid of the idea of weight versus how many I have, this is how many I have, not how much it weighs. You look at this, and this is actually the lowest right here. So now it looks like this is our limiting reactant. But there's another issue. And that is my recipe up here, the balanced reaction. You don't actually need the same amounts of all of these things. You need 2 of the CH4s and 2 of the NH3s. Okay, so because those are the same, I am going to run out of NH3 before I run out of CH4. Okay, because I have less of the NH3 and I need the same amount of both. But I actually need more of the O2. Okay, so is this enough O2? It's a good question. Here's my trick. Okay, this is a trick to do this. Go ahead and take these numbers and divide them by their coefficients. That puts them on the same playing field. Okay, so if you divide these numbers by their coefficients, 5.9, 237 divided by 2 is 2.96. Okay, it's kind of cutting that off. 5.87, 199 divided by 2 is 2.94. And the last one, 6.25 divided by 3 is 2.08. This right here, dividing by their coefficients, just puts them on the same playing field to compare them. Your limiting reactant is going to be the smallest one. So the trick here is just divide how many you have in moles by coefficients and then compare them. Smallest one, that's your limiting reactant. So my limiting reactant is the 200.0 grams of O2. I'm going to run out of O2 before I run out of anything else. Okay, that's how I know. Questions on that? That is so much quicker. It is a quicker method, but here's the thing I want to point out about this method. Okay, there is a small problem with it. These numbers here that I used to figure out what the limiting reactant was. I mean, yeah, you want to know which one's smallest. Divide by the coefficient, which one's the smallest. But these numbers here, they mean nothing. Okay, they have absolutely no meaning other than like telling you what the limiting reactant is. It's just the smallest one. But those numbers here, under no circumstances are you going to use those in any of the other parts of this question. Okay, so as long as you can understand that, this is solely for the purpose of figuring out which one's the limiting reactant and then ignore them. It works, okay? But I've seen people, they do this and then they get this number and they think that it means something, so they should start using that for like another piece. Don't do that. This is meaningless except for what the limiting reactant is. The limiting reactant here is O2. I'm gonna run out of the O2 first, even though it looks like I have the most of it because it weighs the most, but it has the largest molar mass and it's also the one I need the most of, which is why I run out of it first. Okay. So again, any questions on figuring out what the limiting reactant is? Once you know what the limiting reactant is, this right here, that is the only number you need to answer any of the other questions, okay? Only use that limiting reactant to actually answer this question. So since that's the one that I'm going to run out of, that's the one that's going to dictate the maximum amount of the HCN I can actually make. Okay, that's it. So I'm going to take the 200 grams of O2, convert it to moles. I really already did that. Okay, so 6.25 moles of O2. All right. How much of the HCN am I going to make? Well, times it by the ratio. Looking up here, it's 2 HCN, 3 O2. So we're going to put the 3 O2 on the bottom, the 2 HCN on the top. So the maximum amount of the HCN I can make is 6.25 times 2 divided by 3, and around that to 4.17. It's 4.166666 repeating, okay, moles of the HCN. So that's how much HCN I can make. Now, if it asked for grams, it didn't say, but if the question asked for grams, then I just have to convert that to grams. Okay. Any questions over that? What does the 2.08 mean? This right here doesn't mean anything other than it's a tool for figuring out what the limiting reactant is. Okay. So I just took how much of each reactant I have, divided it by the coefficients, and I get a number, and it puts them on a playing field with each other, because it's basically like, because I need more of some than others. It just puts them on the same playing field. So whatever the smallest number is that you get, that's the limiting reactant, but it means nothing. You're just trying to figure out what the limiting reactant is. And once you know that, use that information to figure out the limiting reactant only to actually do the problem. Any other questions I can answer for you? Because this is one of the most complicated problems we've done so far. Yes, you are only going to carry the limiting reactant to the other problems. Always just the limiting reactant. It's kind of like before when we were doing these problems where it was like, okay, so how much of this are you going to make and how much of that you're going to make, where I only had the one reactant. So it didn't matter. I just like, that reactant makes this much. Well, this limiting reactant can make that much. That's what I'm figure out which one you run out of first, and then that's the one that is going to tell you how much you could make. Because if I actually did anything with these other ones, I would get a number larger than this. Like if I used this one here, I'd have a different ratio, I'd get a different number, and I would get something larger than 4.17. I'd get like 4.5. And the fact is I can't make 4.5 because I'd run out of the O2. This is the maximum amount I can possibly make, since that's the one I run out of. Doesn't really matter how much more I have of this. I'm gonna run out of that first. Okay, so let me answer this last bit now. How much of the other reactants, the excess, will actually be left over? Okay, so what I'm going to do is I'm going to again start with the limiting reactant and convert it to moles. And you don't have to do this step every time. You can actually just jump straight to the answer, okay, because you already did it. 1/32.00 grams, 6.25 moles of O2. Okay, so moles of O2. All right. Now, first, I'm going to times it by, I'm going to put the 3O2 on bottom. I'm going to figure out how much of the other reactants I actually need. Okay, so it is actually both 2 for both of them. Okay, it's a 2 in front of both of them. So I'm just going to write a 2 here because I need 2 of the CH4s and I need 2 of the NH3s. Okay, so 6.25 times 2 over 3 is again 4.17 moles of both CH4 and NH3 are used here. Okay, that's how much I need for both. So this right here is I need that much. Okay, that's how much I need. So if that's how much I need, I'm going to go back up here and look at how much I actually have. This minus 4.17 is 1.75 moles left over. And then this minus 4.17 is 1.70 moles left over. So what I'm figuring out here is how much of the reactants I need, how much of the reactants I need, the CH4 and the NH3. And then I just subtract that number from how much I actually used, and it'll tell me how much would be left over.